to improve fuzzing is to let it prioritize to certain code. And by analyzing the data flow, like checking the read and write to those storage slots, we could understand how the dependency between the smart contract or between the functions are. And we could actually prioritize exploring those more interesting interactions between the smart contract or between the functions.
Scraping Bits is brought to you by the following sponsors. MEV Protocol. Maximize your ETH staking value with MEV ETH, exclusively on mev.io. And Composable. Execute any intent on any chain, coming soon to mantis.app. That's mantis.app. And Fastlane Labs, the only MEV and intent-centric team that has a daily deodorant application rate of over 68%.
GM everyone, my name's DeGatchi, the host of Scraping Bits, and today I'm with ChaoFan. How's it going?
Jim, I'm good. Glad to be here.
Glad to have you on. It's great to have a fellow fuzzer on the podcast. I love talking about this kind of stuff, like formal verification. Really grinds my gears in a good way. So having said that, let's give some context of who you are to the people that don't know who you are. Who are you and what do you do?
So I'm currently a PhD student at UC Berkeley, and my research interests are in fuzzing, formal verification, and security. I also worked a little bit on MEV during my research. And I'm also co-founder of Fuzzland, where we work on formal method and MEV. We try to leverage formal method to identify potential profitable opportunities on the chain and use MEV to gain the profit from the opportunities. More before all of those, I was more into Web2 security, and I was also an individual auditor working on a few audits of blockchains and exchanges. I have found critical issues in Web2 softwares, like some really popular sites, for example, CVS. I could go into their internal network. I also find issues on blockchains like Polygon Edge and also Helium, which allows attackers to gain arbitrary amount of rewards or bring the whole chain down. I also find vulnerabilities in exchanges like FTX. I find a few issues that allow anyone to see others' trading information, like position information, and allow others to do some targeted liquidation of some users. So that's about me.
So you've really been in kind of the Web2 security space before you jumped into the Web3 kind of space, right?
Yeah.
And you were doing it manually. What was kind of the transition into going from manual to automating it?
Yeah, I think doing the auditing manually is still going to be an effective way for finding vulnerabilities inside smart contract. But for automation, it's more like finding specific patterns that are leading to vulnerabilities in a smart contract. Right now, you have Slither, you have Echidna, and all those tools available. And all the developers also have those tools onboarded onto their GitHub CI. And there's really no vulnerabilities when it comes to the auditing part. So if you want to find vulnerabilities in your auditing, you likely need to go into the source code and understand it. And also do some inference to see that, this maybe go wrong, which is not likely going to be like a reentrancy or some. It's more going to be like business logic specific.
Yeah. First of all, you started developing this fuzzer with some friends from Berkeley, right? And was it your first ever fuzzer you ever built, or have you done stuff like this prior?
Yeah, previously I was mainly working on Web2 fuzzers. I've built a few for browsers to find vulnerabilities inside browsers and crashing it. It's not really related to Web3, but it's way more interesting because we could actually find some vulnerabilities that could just maybe I send you a web page and I can control your whole computer. But for Web3, what happens is that it's going to be more like for this, maybe the owner could do some rug pull, or the owners could maybe set some parameter incorrect, and maybe there is some little effect.
Yeah, I agree. Like Web 2 and Web 3 kind of vulnerabilities are way different. I think there's a lot more at stake. On Web 3, black hats have an instant reward, basically. If they find a vulnerability, they get instantly paid with millions, if there is millions in there. Whereas Web 2 is more of data breaches and critical information. not necessarily like an instant reward. But I also think like the fuzzing technique would be quite different, because Web3 is all about storage and how they relate to each other, then ordering functions in different ways to kind of get different results, which is what you guys do as well. And you've introduced these new concepts that I haven't seen before, maybe because I'm quite new. You introduced waypoints and also snapshot based fuzzing, which I don't think any other fuzzers do. Like Echidna definitely doesn't do that. I don't know if Medusa does it, but basically, what are these concepts for people that don't know?
So Web2 software and Web3 software are really different. For a smart contract, you need to give a sequence of transactions to break it instead of just sending one transaction. But fuzzing, it's designed for traditional software, which takes one input and gives an output. So if we apply the traditional fuzzing method to Web3 software, then there's going to be two consequences. One is that you just like fuzz one transaction and see that after one transaction is there going to be a vulnerability. Apparently, this is not going to work because the attacker can send multiple transactions, but actually there are a few tools just like fuzzing the smart contract with one transaction. And another way is just like treating the input to be a sequence of transactions in the fuzzer. So the fuzzer is going to execute a sequence of transactions in one run. And for this, it's going to actually waste a lot of effort. So the fuzzer are going to execute the same transaction again and again, apparently, because for the fuzzer, it's just a brute forcing algorithm with some guidance. And during the brute forcing, it's going to execute the inputs. And if you treat a sequence of transaction to be an input, then this sequence could be likely just same as before, but with little mutation on one of those transactions. And other transactions are just the same. So the state they produced also are the same before the mutated transaction. What we do is that we cache the state so that the fuzzer do not need to execute again towards the state before the mutated transaction. By doing so, we could actually save more than 90% of the time, which traditional fuzzer like Echidna or Harvey, they're wasting. So this is our snapshot-based fuzzers concept coming from. And for waypoints, it's actually been introduced really early in a work called Fuzz Factory. The Fuzz Factory is a fuzzer for Web2 software. It says that, like for fuzzing, it's a brute forcing algorithm, but you could give it guidance. The traditional guidance is just test coverage. You can see that if your test coverage increased, then you're going to prioritize mutating this input and trying this input, mutated input again in the future. It's going to be tried more with higher probability. But in the Fuzz Factory work, they consider coverage to be one of the waypoints. There could be other waypoints that could help guide the fuzzer. One could be like comparison waypoint by checking whether we are reducing the distance between the comparison of two sides. In the program, you have if statement, and it's going to have a comparison between one variable and another variable. It could be equal to or like smaller than or larger than. And what happens there is that you just check left-hand side and right-hand side's distance or their absolute difference. And you see that if the fuzzer could reduce it, then you save this input and get it mutated in the future and try it again. So by doing so, we could actually get prioritization for different kinds of things we would like. For a smart contract, we are prioritizing for those that are not only just reducing the comparison distance, we're also checking the data flow, checking the interaction with the storage.
And when you're providing your initial seed, how do you choose what you're trying to find? Do you have like a global invariant you're kind of testing against, or is it just make money?
So actually, the ITFS tool we developed made a lot. It directly generated exploit for taking more than $500K worth of assets from Binance Smart Chain. And it also find vulnerabilities like reentrancy and peer issues in more than 1,000 smart contract holding value with more than $7 million. So our invariant is like this. We don't like traditional fuzzer. We detect reentrancy or specific vulnerability. We just check that whether we can gain profit from the smart contract. This is our only invariant. We check the liquidation of our account.
Yeah, that makes sense. I do a similar thing, like a bit more, because like that's really what matters post deployment. I wonder if you do any pre deployment as well, though.
Right. For pre-deployment, we didn't do that because it's going to be a little bit harder to do the deployment, and it's also going to be harder to do flash loan and also calculating the liquidation.
Yeah, I agree. It's definitely a harder problem to solve because you don't have that initial state and you have to build up the state basically. And so you mentioned you found 500K in Binance. What was the kind of process to get the MVP? I've read the code a bit and you like piggyback off AFL. So why didn't you build from scratch over using AFL? And then what was the process like to get to the MVP state?
Right. So the library we're using is not actually AFL, it's libAFL, which is like a extracted component. So it has all those extracted components from the AFL, which could be reused. It actually like eased the process of our development. They have all those mutators available, so we could directly reuse them. But still, like a lot of parts, like how to generate the ABI, how to encode the ABI, and about all those waypoints we propose, we actually need to implement those things by ourselves. But it's actually a pleasant experience working with libAFL because it's well structured and they have a lot of helper functions and available components that could be directly used.
Yeah, so I guess it's just try and get to the MVP as fast as possible. And what was the kind of process of getting to that stage as well?
Right. So actually, it's been a little bit hard. So actually, in the first week, we already developed the whole MVP, but later we discovered that there are some issues and we have to. So some transaction that should not revert got reverted in our fuzzer, and we have to look into EVM and see what happens there. And actually, for a really small smart contract, there are hundreds of opcode after compiled. So we really have to dive into this opcode and understand what really happens. One thing that blocked us for a whole week is that we're trying to figure out why a Uniswap pair contract is calling the 00001 address on Binance Smart Chain, which has no code on the chain. And later we figure out it's just trying to call the precompile.
Hmm. So it's really just the process was understanding, the EVM, and then I guess how did you determine what was priority for getting something out as early as possible? Obviously, you didn't try and perfect it on the first iteration. So what did you provide in this first iteration? Then go from there.
Right. In the first iteration, we just have a simple example working, and we didn't release the tool for the first version. We just have it internally, and we keep doing testing and fixing the code. And then we finally got to a stage that could fuzz some smart contract on the chain, and we can actually find the vulnerability that has never been discovered on Binance Smart Chain. And at that time, we decided to write a paper and then make it public. But later we still find more issues in our code base, and right now we're keep optimizing it and fixing more bugs.
Hmm. And since then, you've claimed to discover 7,600 vulnerabilities. Is this on chain or from a certain data set of testing? Where does that number come from?
Oh, it's all on the Binance Smart Chain, Polygon, and Ethereum.
Okay. And by unsecured assets discovered, that's from taking, hacking them, then paying it back, or I guess not paying it back if they don't respond. And are these like advanced, vulnerabilities, or is it really just some simple stuff where maybe you find overflow, underflow, or reentrancy? Is there anything really quite advanced, maybe a pickle finance exploit that you can find?
Yeah, so actually, most of the vulnerability find are really simple, I would admit. And for those kind of more complex vulnerabilities, actually, we need some human guidance. We specifically may need some human to write the invariants to see like when could the smart contract go wrong. And we also need some guidance if the attack needs like hundreds or thousands of transactions, the one used in AES exploit, then we may need to get some human instrumentation and human guidance to ensure that we can generate the exploit in reasonable amount of time. Although it could generate the exploit maybe after 10 years or hundreds of years, but we
Perfect.
need to find a way to get it faster. And actually,
Yeah.
when we're doing testing, we just provide 5 minutes for the further to find the issues.
Okay. I think there was like a recent study or paper on it where, the longer you fuzz, some fuzzes actually perform better over a long period of time versus a short term. So it's always in this game about time efficiency and how fast you can really get to these end goals. How do you know when to end, a fuzzing sequence as well? Let's say you're doing, some function sequences, and how do you know when to stop going down a path and stop trying to provide different kind of function sequences and different lengths?
Right. There has been a few papers in academia saying that when shall we stop the fuzzer, and there has also been a research done by Consensus Diligence. What they propose is like a estimator using probability, which aims to calculate the residual risk. It is like the risk saying that how likely is it that if I end now, can I increase coverage again if I keep running it? So actually, if this factor reduces to like a really low amount or below a threshold, then we can say that the fuzzing campaigns are unlikely to find new vulnerabilities or cover new code.
Yeah, I think the only true way to find every path is to know what depends on it. And to say code coverage has been fully covered, I guess you would also have to find the other contracts externally to it that rely on it. But maybe that's kind of out of scope for that main contract then. It's more of like an external contract. It's quite interesting. And then for feedback, how do you really handle that? Is it more of, okay, how far can we get down the path? Or how do you know that, one path makes money with a certain context if there's, so many different contexts? Yeah, so I guess how's the feedback work?
Yeah, so feedback is actually just another name for waypoint. So for us, we're just using comparison and data flow information. Yeah, we don't like particularly calculating how profitable it is, how likely it is going to be profitable for going this path. We just aim to reach 100% test coverage.
Oh, okay, so like going through every single path and function basically. Got you. Yeah, I think it's quite difficult because one path may not lead to something, but if you combine it with another function in a different kind of order, it could lead to something. And so then you have this kind of really complex thing of if there's multiple functions and dependencies, then, let's say there's 10 functions, you would have to fuzz every single function in each order. But then there's also the complexity of calling the same function multiple times, but also in different orders. So it also becomes so much more complex and time computational heavy. So I wonder if you deal with that at all, or is it more of a different strategy you're taking?
Right. The paper we publish, the way we're using is checking whether there are particular interesting data flow that could be triggered after a sequence of transactions. If so, then we're going to get some mutation, like get a higher chance of mutation for this sequence of transactions. Right now, we're doing it differently. We think that data flow is actually not a really good indicator. We find that if we can use large language model, then large language model could actually understand better about the smart contract and find out what is some really interesting sequences of function calls. And it can also generate those kinds of priorities, and we can use those priorities during our fuzzing.
Okay, so that's what you use ChatGPT, right? You kind of just like ask it to generate these priorities, and then you kind of skip on the stack analysis, and that's kind of a replacement in some way, which kind of bridges the gap.
Yeah. There has been a lot of issues in static analysis. So if we just calculate like potential dependencies using static analysis, we couldn't count for those external calls, and the accuracy is also not going to be really good. But for LM, it can actually understand what this external call is doing by just looking at the name, and it can also have a better understanding about the dependency in the same program.
It's quite interesting. What are your thoughts on AI coming into fuzzing as well? Do you think something like deep reinforcement learning is something that's going to take over the fuzzing scene relatively soon, or you think fuzzing is far more superior at the moment?
Right. It's like two part. For a large language model, it does not have a good ability to do reasoning. So if you check recent tweets by those researchers, you will figure out that if you use large language model to do an audit, it's not going to find the issues. It can just maybe identify some really shallow issues that could also be identified by static analysis tools like Slither. So what happens is that we think that for the reasoning part, we should actually use some better way, either through human or it could be through formal verification or fuzzing. But more on the defining what kinds of vulnerability side, we could actually use large language model. We could let the human to determine where can go wrong, and then we translate it using large language model into some formal definition of what can go wrong. It's like a specification, or in other words, invariants. And those invariants got tested by fuzzing or by formal verification. And then by doing so, we could actually find the vulnerabilities. So it's more like human just need to do the imagination, and LM translate this imagination into some formal things. And then those formal things got checked by fuzzing and formal verification. And there is also a proof attached to it, which are like concrete transactions that could reproduce the issues. This is like what we think to be the new paradigm of auditing instead of just doing traditional auditing.
Yeah, I think AI is definitely going to be a force to be reckoned with in the near future for auditing specifically, because it does what is missing from complete automation is reasoning about something. It's basically like replacing a human in the way where it can understand the code base and determine what relates to each other in a very sophisticated way, rather than building heuristics. For example, like what call is using what storage slot. It can kind of reason about the entire thing and saying what's possible actually in this call, or can it be used with like an arbitrary contract that recalls it and it's a reentrancy, or a read-only reentrancy, something else depends on this. It's quite interesting. And then the ChatGPT thing is quite smart, as we can just tell it to do the stack analysis, but it's not really stack analysis. It's really interesting. And I guess why have you thought of any other approaches to kind of tackling this? I think a lot of papers really just mention checking the storage slots of everything and then kind of linking those together in functions. Yeah, is there anything else you really thought of? Maybe writing up a new paper?
Not yet, except from using large language model.
Okay. And I wonder why you choose to open source such a powerful tool. Obviously, with something like this, where you can generate exploits, right, for any contract, there is, I guess, it comes back to you as you becoming liable in a way for someone else's use of it. Like, let's say, a black hat wanted to just scan every single contract, run it through your, open source fuzzer, and then generate an exploit, then exploit it. Then how do you really go process that? Because it is quite a relevant thing and highly possible.
Yeah, the reason we want to get it open source is that we want the developers and the auditors to use our tool and potentially report some issues with our tool, so we could fine tune our tool and make it better. And in the meantime, if the black hat use our tool, they couldn't like do batch scanning. They couldn't scan the whole Ethereum network and see whether there are vulnerable contracts. Our current tool could only allow like one IP address run the same campaign. In the meantime, there could not be other campaign because we highly rely on Etherscan and highly relying on Graph. So all of these maybe hinder the use of Black Hat, but more fostering the use for those like auditors and also developers.
Yeah, I mean, I imagine if someone is a black hat looking at bytecode, right, they would be able to code and, just take this open source project and then modify it in like a private repo and kind of remove the dependencies and just run it through that. So, I mean, that's still, a possibility. But I guess that's a possibility with everything, right? But even with the one campaign, they can still do that.
Yeah, but the same thing could happen to all other tools like Akina, Slither, and Misero, right?
Yeah, but they're not generating the actual exploits though, right?
Right. Misero could actually also generate the concrete transactions or the exploits.
I guess you can look at it from different perspectives. So I wonder what it would take to kind of generate something like a pickle exploit where, there's arbitrary addresses being called and you can create like a contract with whatever functions you want to put in it. I don't know if you're familiar with the pickle one, but, it adheres to the interface of the jars, and then it has, a sequence of functions. It has like 7 functions in one jar, and there's 2 of them. And then it goes through like the curve, does it like a jar swap, jar for jar, and then does all that stuff. It's very intricate and very sophisticated. I wonder if you have any idea, how can you even accomplish that?
Right. I guess the attacker is more like doing manual analysis, but for our tool to find this kind of issues, it's going to be a bit hard, or it's going to take really, really long time. But I wouldn't say that our tool cannot find this. What happens is that our tool supports manually adding the guidance, so that suppose that there may be go wrong, we could first let our fuzzer prioritize exploration of those places, and then maybe with all those prioritizing information, you could reduce the time of the fuzzing. And in the meantime, we're also using concolic execution to reduce the chances that the fuzzer got blocked by some really complex conditions in the program.
Yeah, and I assume you use something like bound analysis to kind of remove all the inefficiencies from symbolic execution. And for the people that don't really understand, what is concolic execution?
Right, so it's like just another name for symbolic execution combined with concrete execution. So it's like you execute a program, and in the meantime, you collect all the conditions encountered. And whenever you see some conditions, you try to flip it and use the solver to generate the input that could travel to the different paths than your concrete execution is.
Interesting, yeah. A big thing about smart contract fuzzing is that it's stateful. What are the main problems you found while building this tool and running it?
Yeah, I think the statefulness is the greatest problem, and this is what we're trying to resolve. But actually, if like we can use the previously mentioned method to get some prioritization, actually those heuristics could help a lot to resolve this overhead incurred by statefulness.
And how would that work at a technical level?
So the main thing to improve fuzzing is to like give it guidance or let it prioritize to certain code. And by analyzing the data flow, like checking the storage slots and checking the read and write to those storage slots, we could actually understand how the dependency between the smart contract or between the functions are, and use those information. We could actually prioritize exploring those more interesting interactions between the smart contract or between the functions.
And what do you classify as an interesting interaction?
All right, so interesting interaction on the data flow side is like I write to the slot with some really unique value, and then someone else read it. Then we say that the previous transaction that write to the slot or previous function call that write to the slot should be before the transaction that lead to the read to that storage slot. So it's like the later one depends on the previous one. And this dependency is interesting.
And then you can also do, if something is reading it, right, you would obviously put the right before, but let's say you have two different functions that read the same storage variable. How do you really like fuzz the order of these functions as well? Like let's say you have two different functions that rely on the same storage slot. How do you process that on a fuzzing level?
If both are depending on the same storage slot but not mutating it, then we say that these two functions are not really dependent. And so we don't care like however we order these two functions. It's like we'll just treat it as not interesting.
Oh no, I mean like they are dependent. So you have the write and then you have the read, but there's two functions that read from that write. And obviously there's different kind of ordering for this. Let's say you can have them one after each other. So there's like three different functions, or you can have just two where it's the write and the read, and then write and the read of the other one. So I guess how does the fuzzer really determine how to order these at a technical level?
Right. It doesn't really matter to the fuzzer how it ordered this. It can just like try it again and again, try different kinds of orders. What we do is that we see that is it more likely to be interesting? And if so, then we let the fuzzer try more of these. And if there are dependencies between each functions, then we could just let the fuzzer try all of those kinds of orderings.
Yeah. And I guess what are the problems you're facing now, and what kind of advancements are you trying to make on ETY fuzz?
Yeah, the greatest issue right now we're trying to figure out is how to elegantly liquidate the token that we receive from the smart contract. Right now, we're using Uniswap to liquidate the token, but apparently there could be hundreds of paths on the Uniswap on Uniswap that we could liquidate the token, and we don't know like
Yeah.
which path could yield the best quote. So we actually built a solution surrounding this using convex optimization to figure out what is the best path. But still, like it's taking really long time and really not suitable for fuzzing because fuzzing needs to like finish the full execution, including calculating the liquidation in less than.
Got you. And on the topic of Uniswap, you guys are trying to build, this uncommon arbitrage tool. What is that?
All right, so we're actually using fuzzing to identify those kind of uncommon arbitrage opportunities on the chain. So one example we have is that there is a token that is doing pre-sale. It's selling a token at a way lower price than the price of its Uniswap pool. So our tool could generate like the full two transaction. One is to buy from the pre-sale and another is to sell it on the Uniswap pool directly through fuzzing. But if you just traditional MEV bot, pattern-based MEV bots, you're unlikely to identify those kinds of vulnerabilities because there are also some checks in the pre-sale function. To bypass those checks, you need to try a lot of times. With fuzzing, we could actually easily find out how to do the pre-sale. But for pattern-based, they need to spend way longer time or they could simply not find those opportunities. And a bigger example we encounter is like there has been a protocol that has a lot of tokens, staking tokens, governance tokens, and all of those. There are like 10 tokens, and our tool actually generates an arbitrage transactions with like interactions with all those 10 tokens, and then we made a profit of around 10K. So what happens is there is arbitrage between one token, and then that token is a LP token, and then we try to sell that LP token. We try to like burn that LP token and then get another token, and all of those. There are like 40 transactions to do the whole thing.
Yeah, it's super interesting. And are you trying to make this a service, or is it really just an in-house thing?
We're still trying to determine that. It's more like you still need to define like the target and also provide some heuristics or provide some
Okay.
information to the fuzzer.
Right, so none of this is really 100% automated.
Nothing is automated.
Okay, got you. And even with the fuzzer, is that fully automated, or is it still got some human interaction with it?
For the fuzzer, it's fully automated, but if you want to find those arbitrage opportunities, you still need to like give the target, give the guidance, give a lot of informations, like what liquidation paths you should use. Do you need to use Uniswap or SushiSwap or PancakeSwap?
Okay, interesting. Yeah, it wouldn't really make sense to sell that if it did work really well, because if it worked really well, it would make a lot of money. And what's the point of selling it if it makes money, right? And you're also doing token security, so you're basically fuzzing tokens to see if they have any rug pull capabilities. So if the owner has some access to, mint all the tokens and, sell them all on Uniswap, just wipe out the liquidity. You guys identify that, right?
Yeah. We're trying to identify risks like what Gold Plus is doing. What happens is that we have a set of invariants and we check whether the token behaves just like the invariants or is it going to violate it. For example, USDT is going to violate it because it has a blacklist function. It's like you buy the token and you couldn't sell it after owner called the blacklist. So for some reason, we still classify USDT to be a token with high rug pull risk.
Yeah, I mean, it is completely centralized, right? If someone does a hack, for example, they just blacklist that address. You can't really do anything with the money, it's just stuck. And then you're also doing, real-time defense. So this is more of front running.
Yeah. So I think recently there has been a lot of like interest on front running the attack. BlockSec has been working on that for a few years, and there has been recent paper from Purdue on how to instantly like generate the exploits from attackers' exploit that are going to like transfer the assets instead of to the attacker, but instead to you. So actually we're working a little bit on that. Today, like almost all hackers are using private transaction. So you can only see the transaction after it got included into the block. And after it included into the block, you can do nothing about it. So all those strategies that are proposed today or made public today are not going to work. They couldn't even see the exploit before it got finalized. So there is no way to front run it.
And so how are you front running these exploits then? If they've already gone into the private mempool, you don't know that they exist until it's, confirmation. So how was yours really working in real time?
Right. So our way is just to give each address confidence level. And if it has higher risk, then we're going to continuously monitor that address. And whatever it interact with, we're going to see that whether given the attacker's transaction, given this potential attacker's transaction, can we hack the smart contract it is interacting with using formal verification and fuzzing? And commonly, we can actually find the exploits with the hint of the attackers or the potential attackers. So instead of monitoring to see whether there are attack happens, we actually just see whether there are pre-work of the attack happening. And we try to prevent it way before it happens.
Right, so like you are seeing the setup transaction, right? Okay, you identify this transaction, then you see you kind of I guess fuzz with that as the initialization state, right? And then continue from that to see if anything else happens. There's also the thing, I guess you don't really need init transactions to set this up. Someone could create a contract and then call it. That would be like a setup thing, but you can really do that in one transaction though, so
Right. So today it's still like split. The attacker deploy their attack smart contract, and after like a few seconds, they call their attack contract to do the attack. So during this period, we could actually analyze the attacker's contract and take the exploit inside the attacker's contract out and use that exploit to hack it.
yeah, so it's really before they even get access to the private mempool. Yeah, I guess that's just a flaw from the Black Hatter's perspective, because if you really wanted to, you would just do it all in one transaction. You create the contract, predefine what the contract address is going to be like, and then do it from that. I guess there's no real workaround from that, but all the other ways, it definitely would work, theoretically. And have you actually prevented anything so far?
Not yet. Because of the private transaction, our initial solution didn't work. Our initial solution is just like what the papers proposed, using the attacker's transaction and do all those stuff.
Yeah, just generalized front running.
Yeah, it didn't work.
Yeah, I mean, there's always the naive black hats that just use public mempool and they just get front ran like instantly by multiple people.
Yeah, most of those cases are because of the attacker's transaction is out of gas instead of like really just because you can front run it. So for recent attacks like those, most are due to out of gas, and then someone could use really high gas to just send the transaction after they see that transaction.
I mean, it would be out of gas because the transaction in front is changing the state, so the one behind it's going to fail because of that. So I've seen it live as well. It's kind of weird. The private mempool is definitely like a good and bad thing. And it's more of like an architecture problem to kind of fix this stuff. But stuff like fuzzing is definitely a step in the right direction and definitely needed. I think manual auditing will only get so far in terms of scalability. The only really way to scale is just to have more hands on deck, which, requires people to be interested in it, work on it, learn it. But I guess it only gets so far. So where do you see the kind of future of auditing pre-deployment and post-deployment in terms of fuzzing, manual, the grand landscape of the crypto sphere?
Right. So I have some experience at traditional auditing firms where a group of auditors got assigned to a project and they do auditing. Also has been involved in some Spearbit and C4 contest. So I think the best way to do auditing is more like competition-based method, using like for Spearbit and C4 for pre-deployment auditing. And for post-deployment auditing, I think there are two good ways. One is you have a time log. So whenever you see like larger transactions, then you should let it be there for like an hour until someone fully like analyze it. Although this would lead to some centralization issues, but actually this would work really well and save a lot of assets. Another way is like using fuzzing or using some other method to build like a firewall for the smart contract. Whenever you see there is an attack, we try to either shut the smart contract down or we try to do the attack by ourselves.
Yeah, it's a very complex problem to see. I think AI is going to be quite interesting the more it advances as well. I know there's one person, Lucas from Pentestify, that's working on AI solution, which from what I've heard is gaining quite some traction and it's actually working. So in terms of that, I'm quite scared. I don't want to build something and then AI just replaces it, I wonder if that's like a path you might explore as well, like going full AI instead of a fuzzer or partial AI.
Right. So the company I co-founded, we're more like an AI company instead of a traditional auditing or just working on fuzzing company. What we are trying
Mm.
to do is more like democratizing the use of formal verification and fuzzing. But we don't think fuzzing or formal verification could be replaced by AI. We think AI is just lowering the barrier to access those kind of powerful tools. So
Mm.
with AI, maybe in the future, people could just audit the smart contract they're interacting, not just like rug pull risk. They can also understand, is it going to be hacked in the future? Just
Hmm.
inside your wallet by telling AI something they want to know, and then it got turned into some queries for fuzzing and formal verification.
Why don't you think it will fully replace something like fuzzing?
I mean, like, I got reduced to a really simple problem if you think about this. If
Hmm.
large language model could replace fuzzing or replace formal verification, then it's actually could solve our SAT problem, which is MP problem. And then by doing so, you're basically just saying that with large language model, you could prove P equals MP.
And what is P equals MP?
Oh, okay. It's like a problem that is not resolved. People commonly say that if you can solve the SAT or SAT problem, then you could solve
Mhm.
all other NP complete or NP hard problems. So basically, by doing so, there is no longer any barriers in calculating things on computer. There's no longer barriers on doing convex optimization and all of those. And it's going to just be like the human society or the whole computer research is going to be like improved, or in other words, like completely broken.
So basically, anybody doing fuzzing is fine for the foreseeable future.
Yeah, I would say that, but still, like AI could potentially become better and better, but it couldn't gain the same performance as fuzzing or formal verification.
Got you. Yeah, I was talking to someone before, and it's so expensive to train one of these things. And even then, the amount of money you would spend on training it, you could build a system that makes a fuzzer run insanely quickly. And depending on how efficient it is, it just could be a way better investment at this time, at least. Maybe in the future it's going to happen, but eagerly waiting for that day. And I guess anybody wanting to get into fuzzing and formal verification, what would you do to kind of restart your career and get to the point where you're at now?
I guess started pretty early in the smart contract auditing business, and at that time, the only tool I'm using was Slither. If at that time I could build some fuzzing solution, I would actually apply it, and I can actually beat a hacker who steal like millions of dollars. I would recommend folks to look more into fuzzing instead of just doing static analysis, because static analysis or just using large language model, it's not going to be accurate. If you're using fuzzing, you could certainly reduce huge amount of false positives and false negatives during your discovery process of vulnerabilities.
Hmm. Yeah, I agree. Fuzzing is basically, putting inputs in and seeing the result. And then from the result, you're determining what to do from that. It's basically like you're doing it yourself in an automated way and kind of brute forcing. And you're just trying to make the brute forcer as smart as possible, right?
Yeah. And it's not really hard to onboard to fuzzing or formal verification. Like if you're a Move developer, then you're automatically onboarded to their formal verification tools.
Yeah, if you really wanted to start doing a fuzzer, you would just import like REVM, just like an EVM type thing, and then build something that randomly generates, inputs. You could just increment by one. There you go, there's a fuzzer. Very dumb one,
Right.
but at least it's a start, right?
Yeah. It's really simple. Fuzzing is not like some rocket science. It's more like everyone could do it.
It's more about the kind of techniques you use to make it smarter and smarter and more efficient. That's where it really gets the most leverage.
Right.
We are hitting an hour now, and I don't want to take up too many hours of your time. So it was a pleasure having you on, man. It's great to finally chat, and I'm really excited for the future of Fuzzland. I think you guys are doing great things, and the more time goes on, the more innovation you guys are going to do, and you've got like a great team behind you. It's going to be very interesting to see how you guys evolve the space.
Thank you. Really nice to talk to you.
Yeah, likewise. And for anyone else wanting to come on the show or suggesting anyone to come on the show, just DM me on Twitter at scrapingbits or email me at scrapingbits@gmail.com, and I'll review the request and we'll see what we can do. Otherwise, thank you so much, ChaoFan, for coming on, and I hope others will listen to some future episodes. Take care.